In this video, we are again focusing on trigonometric ratios and specifically their inverses. So in this lesson, we are going to focus on only the cosine inverse. Now we've talked already about the sine inverse and how to use that one. Now we're going to move on to cosine. So sine inverse is typically used when you're looking for a missing angle and you have the opposite and the hypotenuse information. So sine inverse is used to find x degrees, and using the equation x equals sine inverse of opposite over hypotenuse. Today we're going to focus on cosine inverse. And that's going to be used to find a missing angle x by setting up the equation x equals cosine inverse of adjacent over hypotenuse. In the next lesson, we'll talk about tangent inverse. Tangent inverse would be used to find the missing angle x by setting up the equation x equals tangent inverse of opposite over adjacent. Now let me show you where this comes from. Focusing again only on the cosine ratio, if we wanted to know the missing angle x, we would have to start with setting up the cosine ratio. So the cosine ratio, remember, is always the adjacent side and the hypotenuse. So A would be the adjacent side, C would be the hypotenuse. So if we were setting up the cosine of angle x, that would be A over C. Now if I wanted to get x by itself, meaning I just want x degrees equals something, that means that I need to get rid of the cosine in front of it. Well, to get rid of a cosine, we can't multiply it out, divide it out, subtract it, because it's not a typical mathematical function. It's not a regular operation like plus, minus, multiplication, and division. Instead, it is a function. It is something that we have to take the inverse of. So consider, for example, if I wanted to get rid of c, I would just do times c on both sides to get rid of it. The same idea happens when we use inverses of trigonometric functions. So what's going to happen is we're going to take the inverse on both sides, so cosine inverse of cosine, they cancel each other out. And when I take cosine inverse on the other side, that's our next step. So we would take cosine inverse on each side, and that leaves us with x equals cosine inverse of A over C. Now, if I wanted to find the cosine of y and use that to find the angle y, we would do the same situation using angle y. We would set up the ratio of the adjacent side to y and the hypotenuse. So the cosine of y would be b over c. Then, to get y by itself, we simply need to move the cosine over by taking the inverse. So that leaves us with y equals cosine inverse of b over c. So it's the same ratio, you're just taking the inverse of that ratio to get that angle measure by itself on one side of that equation. Now let's do some examples. The most basic example we could do is just by taking the cosine inverse of a given ratio or a given decimal number. So to find the measure of angle A here, remember we want to keep our calculator in degree mode, so I have degrees selected. And I need to find the measure of angle A. So I'm going to take cosine inverse on both sides. So it's going to cancel out over here, and it's going to become cosine inverse on the other side. And then whatever else was over there, that goes inside the parentheses. So in Desmos, we just click Functions, Cosine Inverse, and then type in that decimal number. And that gives us the angle measure 42.00. Since we are measuring to the nearest tenth, that's just going to be 42.0 degrees. Let's do one more like that. Finding the measure of W, if cosine W equals 0.6157, we're going to take the inverse of cosine on both sides, which would leave us with W equals cosine inverse of that decimal number. So functions, cosine inverse of 0.6157. And that gives us 51.99. Okay, when we have this, we've talked about rounding quite a bit here. If I have 51.997 and I want to round to the nearest tenth, that means I want to keep that first decimal place in the tenth spot. Based on the number beside it, which in this case is a 9, that's going to bump this up to what would be like a 10. But we can't write a 10 in that decimal spot, so what happens is it's going to bump the next number up. So our final answer here is going to be 52.0 degrees. Now let's get into some triangles. Use cosine inverse to solve for the missing angle. We're just going to call this angle X, and we're going to round to the nearest tenth. So the information that we have is the hypotenuse, which is directly across from the 90 degree, and we have the adjacent side, which touches that angle. So just from the given information, the only thing we can use is cosine. So let's set up that ratio. Cosine of X is adjacent over hypotenuse. So that's 13 over 20. If I want to get X by itself, I want just X equals, then I need to take the inverse of cosine on each side. That leaves me with X equals cosine inverse of 13 over 20. And that's what we type into Desmos. That gives me 49.45. So just using that 5, that's enough to bump that 4 up to a 5 in the 10th place. So X is approximately 49.5 degrees. Number 3, use cosine inverse to solve for the missing angle, round to the nearest tenth. So here we have our missing angle. I'm going to call it X. We have the hypotenuse, and we have the adjacent leg which connects to that angle. So cosine of X equals adjacent over hypotenuse, so 6 over 8. We're going to take the inverse cosine and calculate that. So functions cosine inverse 6 over 8 gives us 41.40. So we're going to look at that 0. That does not bump the 0.4 up any, so that's just going to be 41.4 degrees. Number 4. Same setup. We have our missing angle X. We have the hypotenuse directly across from the 90-degree angle. We have the adjacent side of that angle. So we're going to have to use cosine and set up adjacent over hypotenuse, so 4 over 5. Take the cosine inverse, so X equals cosine inverse of 4 over 5. And calculate that in Desmos. That angle measure is 36.86. And we're rounding to the nearest tenth, so that would be 36.9 degrees. Number 5, now we have all three sides, but we're told to use the cosine inverse. So from the given angle that's missing, we need to use adjacent and hypotenuse. So immediately, I can identify the hypotenuse. And based on the angle x, the other side that attaches to it is 48. So now I can set up my cosine ratio. So cosine of x is going to be adjacent over hypotenuse, which is 48 over 50. So x is going to be the cosine inverse of 48 over 50. Let's calculate that to find our degree measure. That gives me an angle measure of 16.26. And we're rounding to the nearest tenth, so that's going to be 16.3 degrees. Lastly, number 6, same setup. We need to find this missing angle, but we are told to use cosine. So with cosine, we need to identify the adjacent and the hypotenuse. I can start with my 90-degree angle. Directly across from that is going to be the hypotenuse, and the side that attaches to the angle is going to be adjacent. So we can set up the cosine of our missing angle x is the adjacent over the hypotenuse. So 51 over 85. Now take the cosine inverse on each side of that equation. That means they cancel on the left, and on the right we have cosine inverse of 51 over 85. Functions, cosine inverse 51 divided by 85. That gives us an angle measure of 53.13. So if we're rounding to the nearest tenth, that's just going to be 53.1 degrees.